Hello everyone, this is Sukruti Joshi and we are going to start a topic which is green chemistry. Till now we all know that what is actually chemistry is, right? So what we do in chemistry? We generally do study of chemicals. So in our routine life, chemicals plays a very important role. When we understood this thing, at the same time we have to understand that the chemicals can actually cause certain hazards. So they are cons. Cons means disadvantages. Chemicals when came into picture, along with the advantages, it also brings certain disadvantages. Now, here what will happen that such kind of disadvantages will lead to certain new development. What is the meaning of new development? So the new branch came into existence here. Which is that new branch? The new branch which actually gives the solution for disadvantages of the chemicals or usage of the chemicals basically. Okay, so here the particular branch which came into picture is known as green chemistry. Here, as you can see from the word itself, green chemistry. Chemistry generally can be used for study of chemicals. What is the meaning of green chemistry? So green chemistry actually involves the applications of greener chemistry into their own, like what we do, we actually synthesize certain type of chemicals which will lead to the latest or the new technologies which will result in the benefits, or it will give us a solution for the chemicals which can cause harm, right? So the branch of chemistry in which we actually provide solution for the disadvantages caused by chemicals. This is the meaning, this is the actual motto behind innovation of a branch which is known as green chemistry. Okay, so let's see that what is the meaning of green chemistry actually, right? So it is defined as the branch of science which utilizes a set of principles for the invention, design, development and implementation of chemical processes, certain products that reduce or eliminate the use and generation of hazardous substances. As I told you earlier, it basically leads to the generation of certain hazards, right? The usage of chemical actually leads to the hazards. Here what we need to understand that what we do here is basically we provide solutions to that hazardous processes, to the I can say that it's basically the application, or we will actually found the options for hazardous substances. Okay, the approach in chemistry is protecting human health and environment, and it represents a significant departure from the traditional methods previously used. So we have seen that the old synthesis or the old organic methods actually gives the results, but they also gives us certain byproducts. This kind of byproducts actually it's very harmful for the environment, it's very harmful for the person who is using it. So what we do here is basically we found the alternatives for that things, right? So that is how it works. Okay. Now green chemistry is defined in the Linthros article as having the three major time periods of development. Here I can say that so what we can understood here. So by this, it's before 1993, the early origins of pollution control and hazardous awareness or pollution was observed. Okay, so in this time period, the EPFO, that is, was evolved with strict command and control with end of pipeline technology to active efforts to prevent pollution before it happened, with the risk analysis early on in the process. The next time period is between 1993 and 1998. In this time frame, a chemical philosophy evolved. It is a combination of several chemical concepts, a conceptual framework that can be used in the design of chemical processes, achieving environmental and economical goals by way of preventing pollution. So this comprises ambient reaction conditions, renewable feedstocks, and minimization of reaction steps. The third time period is from 1999 to now, which has seen an explosion of green chemistry based on the scientific articles. Now, let's talk about the benefits of green chemistry. So, green chemistry holds the promise of reducing health and environmental damage. In the past, we have focused on cleaning up the toxic masses, which is a moment to design chemicals that are safer for the environment as well as for the human beings. Okay, so basically 12 principles were evolved of green chemistry. So Paul Anastas, who is from USA, so that person who belongs to United States Protection Agency, and John Warner developed 12 principles which help to explain what the definition means in practice. So the principles cover such concepts as the design of process to maximize the amount of raw material that ends up in the product, the use of safe environment benign substances including solvents whenever possible, the design of energy efficient processes, the best form of waste disposal, not to create it in the first place. Right? So let's talk about the 12 principles here. First principle was prevention. So it is better to prevent waste than to treat or to clean up the waste after it has been created. Second principle involves atom economy. So synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final product. Third one is less hazardous chemical synthesis. Wherever practicable, synthetic methods should be designed to generate substances that possess little or no toxicity to human health and to the environment as well. Okay. Fourth principle, designing the safer chemicals. So it can be said that whenever practicable, synthetic methods should be designed to use and to generate the substances which create less hazardous substances. Okay. Fifth one, what we do is we actually design the safe chemicals, the synthetic processes. Okay. Then fifth one is safer solvents and auxiliaries. Of course, the use of auxiliary substances, say for an example solvents, agents, should be made whenever possible and innocuous when used. Sixth one is design for energy efficiency. So what we do is energy requirements of chemical processes should be recognized for their environmental and economical impacts and should be minimized, right? So seventh one is use of renewable feedstocks. That is, a raw material or feedstock should be renewable rather than depleting whenever technical and economical practicable, right? Eighth one is reduce the derivatives. Unnecessary derivatization, which is use of blocking groups, deprotection, temporary modification should be minimized or avoided. The generation of the waste should be avoided, right? Ninth principle is catalysis. So certain catalytic reagents are superior to stoichiometric reagents, so that should be developed. 10th one is design for degradation. This chemical product should be designed so that at the end of their function, they break down in the innocuous degradation products and do not persist in the environment, right? 11th is real-time analysis for pollution prevention, which is analytical methodologies need to be developed for it. 12th is inherently safer chemistry for accident prevention. So we should prevent the explosions, certain releases, energy releases, etc. Right? Let's talk about the applications of green chemistry. So here, as you can see that one of the example we can take here is green solvents, right? So the ester solvents typically, so specialty solvents, fusible solids, supercritical gases such as SCCO2, that is supercritical CO2 gases, then propyl laureate, then rapeseed methyl esters. Such kind of chemicals can be particularly generated so that we can create certain organic methods which can create less waste. Okay, specialty solvents like glycerol carbamates, fusible solids like hydrogenated castor oil, stearyl cearate, this should be created so that we can get to know the actual techniques, okay, so that we can have certain less hazardous substances. Okay, this is all for this session. We can see further in our next sessions. Thank you so much, everyone.